check. Hi Safura. Yeah, கேக்குது. Fine. Okay. All right. Hi Divakar. I was stuck in traffic. It was so bad in the book from Central to Nanagar. It was so bad. It was for 3 kilometers 20 minutes மேல ஆச்சு வரக்கு. So yeah. Okay. All right, people. All right. All right. Okay. Fine. Before we get into wave optics, இன்னும் என்ன எத்தனை நாள் இருக்கு? 30 நாள் இருக்கு. 29 days for exam. Okay. And as the usual thing, what ask me your NEET related queries. Okay. This will go for like கேளுங்க I'll yeah, because you have only 29 days for your exams and you might be stuck எங்கயாச்சு. Okay, you wouldn't have any clue where என்ன பண்றது அடுத்தது. கரெக்டா? I was in exact same state too. அப்போ வந்து my seniors they helped me. They are currently my college seniors as well. Fine. So yeah, I'll help you. Consider me as your senior or a mentor or brother, whatever, bro. Ask me anything about your preparation in this 1 month. எப்படி போகணும்? If any sort of help which you want from my side, I'll try to do the best, because இந்த மாதிரி ஒரு platform I didn't have when I was preparing. Okay, I didn't have Medicos who actually solved என்னோட ப்ராப்ளம்ஸ் எல்லாத்தையும். ஸோ யா, கேளுங்க. I'll try to answer every one of your queries. Okay, all right. And Fatima is going to write a JEE exam tomorrow. All the very best. Government Medical College கிடைக்க can we crack in 1 month? என்ன நான் பார்த்துருக்கேன் ஜெயசுந்தர். I have seen people. Okay, நான் நேர்லேயே பார்த்துருக்கேன் who got government medical colleges with ஒரு 1 month 1.5 month preparation அந்த மாதிரி. Okay, it's possible. அதுக்கு வந்து but they had to put so much effort than us. Okay, நாங்கள் ரெகுலராக படிக்கிறவங்கள விட those people கடைசியில் they wanted to get into NEET, and அப்போது அவங்கெல்லாம் வந்து ரொம்ப எஃபர்ட் போட வேண்டியதாக இருந்துச்சு. பட் ஸ்டில் they did get, okay, லாஸ்ட் படிச்சு இந்த டைமில் your only priority should be solving questions. Okay, concept தெரிஞ்சுட்டு solve questions. You'll definitely get it. Don't lose hope. Okay, when you feel like you're getting distracted அப்போனா just remember that there are 20 lakh people, okay, about 20 lakh people who have already started உனக்கு முன்னாடி, or at least 10 lakh people, okay, they've already started உனக்கு முன்னாடி. They're already ahead of you in preparation, in terms of time, in terms of practice, in terms of everything. So to get ahead of them, you have to put in so much effort than them. Okay, it's all right. Fine. In few days, what did you do for revision in physics and chemistry? Okay, fine. Sleep for 3 days, full effort. நல்லா பண்ணுங்க. டோன்ட் சாக்ரிஃபைஸ் ஸ்லீப். ஏன்னா வந்து ஒரு கட்டத்துக்கு மேலே even after you put 24 hours in a day into something, your work won't be done ஒழுங்கா, because it is essential for our entire body and mind to take a break, to have some rest. Without sleep you won't be efficient enough. Okay, fine. So last minute நான் physics chemistry என்ன பண்ணேன்னா, chemistry அதான் நான் ஆப்வியஸ்லி சொல்லியிருப்பேன். I don't know if you remember Safura. Chemistryக்கு I have a note. Okay, in that I have all the inorganic chemistryக்கு மட்டும் அந்த ப்ராப்பர்ட்டிஸ் எல்லாம் வந்து டேபிளில் I would have written it in a graph formatல. So say this is boiling pointக்குன்னா, boiling point of some random group of elementsக்கு வந்து இந்த மாதிரி I had a graph. அதில் வந்து I used to plot, and இந்த மாதிரி இமேஜஸ் பிக்டோரலாக ரெப்ரசன்ட் பண்ணும்போது comparison of various properties of elements became easier. This is not this doesn't belong to anything. Okay, but still இந்த மாதிரி ஒரு ரெப்ரசன்டேஷனை இது வந்து ரைட்டிங் இஸ் ஈஸி அண்ட் பட் ஆனால் இது வந்து எக்ஸாமில் வந்து நீ வரைஞ்சி பார்க்கணும், உனக்கு மெமரியில் இருக்கணும் இந்த டயக்ராம். ஃபைன், ஓகே. I revised this. Okay, and organic chemistry I revised entire organic NCRT ஃபுல்லாக படித்தேன். and then coaching material கொஞ்சம் இருந்துச்சு, அதில் வந்து I solved questions கொஞ்சமாக. ஏன்னா அதில் வந்து மெட்டீரியலில் வந்து யூ ஹேவ் கொஷின்ஸ் லைனாக போயிட்டே இருக்கும். அதில் வந்து நான் அங்கங்கே சர்க்கிள் பண்ணி வச்சுருப்பேன், அந்த கொஷின் நம்பரை மட்டும் பார்ப்பேன். பிகாஸ் அதை ரெஸ்ட் those were the questions which I felt difficult. I felt were okay, fine. And physicsக்கு I revised few concepts because ஆல்மோஸ்ட் எல்லாமே ஞாபகம் இருந்துச்சு அந்த டைமில். ஃபியூ கான்செப்ட்ஸ் அப்பப்போ மறக்கும். இந்த கரண்ட் மேக்னட்டிசமில் அபவுட் ferromagnetic substances, about and susceptibility அதெல்லாம். ஓகே, ஸோ அந்த மாதிரி சின்ன விச்வர் உங்களுக்கு எந்த டாப்பிக்லாம் கொஞ்சம் டவுட்ஃபுல்லாக இருக்கோ, இதெல்லாம் கொஞ்சம் கன்ஃபியூசிங்காக மறக்கிற மாதிரி இருக்கோ, ஸ்டடி ஆல் தட். ஓகே, அதை மட்டும் பார்த்து வச்சுக்கோங்க, தியரி மாதிரி இருக்கிறதெல்லாம். அண்ட் தட்ஸ் ஆல். ஐ திங்க் தட் வில் ஒர்க் ஆல் ஃபார் ஃபிசிக்ஸ். பிகாஸ் இத்தனை நாளாக வந்து யூ ஹவ் பீன் ப்ராக்டிசிங், யூ ஹவ் டோல்ட் மீ யூ ஹவ் ஸ்கோரிங் வெல். ஸோ solving more questions and preparing for exam, that comes different. But for revision, this is all I did. Okay, so physics chemistry this is what I did. For physical chemistry, same. formulas only I revised. அதுக்கு மேலே I didn't have time and it wasn't necessary to. Okay. Okay. Okay, good. Nice, Sundar. Jay Sundar. Question solving concepts எல்லாம் பண்ணுறோம். Yeah. பாத்திமா முடிச்சு விட்டாங்க ஜெய். ஓ, நான் என்ன இன்னைக்கு பேப்பர் கஷ்டமாக இருந்துச்சா? இதில் எப்படி ஸ்கோர் பூஸ்ட் பண்ணுறது? ப்ராக்டிஸ் ப்ரோ. ஃபிசிக்ஸ் பொறுத்த வரைக்கும் பூஸ்டிங் ஸ்கோர் வந்து யூ கேன் பி இன் எனி க்ரைட்டீரியா. ஓகே, ஒன்று வந்து யூ வில் பி ஏபிள் டு சால்வ் பிஃபோர் எக்ஸாம். ஆனால் அவன் எக்ஸாமில் சால்வ் பண்ண முடியாது. தட்ஸ் பிகாஸ் ஆஃப் ஸ்ட்ரெஸ். ஸோ ஸ்ட்ரெஸ் ஹேண்டில் பண்ண கற்றுக்கோங்க ஒன்று. ஆர் எக்ஸாம்லேயும் சால்வ் பண்ண முடியல, அதுக்கு முன்னாடியும் சால்வ் பண்ண முடியலன்னா that's because you didn't know the stuff. Okay, so அப்போ வந்து you have to study the concept of derivation and then your question solving. Okay, the more you start solving questions, yeah, the better your understanding over the subject gets, and with better understanding you'll definitely get better marks. I can promise you this. Okay. This is for Abia. Okay. Okay. So class ஆரம்பிக்கலாமா? ஆரம்பிக்கலாம் நினைக்கிறேன் கிளாஸ். கரெக்டா? Okay, if you have any other queries, chat like கேளுங்க. I will definitely answer to them or reply to all those doubts. Okay, fine. All right. For those who don't know me, this is me, Rihan, from Madras Medical College, doing my MBBS anga second year MBBS. Here to take wave optics for you in Vidamuyarchi 2.0 series or crash course. Okay, fine. So yeah, people, this is your beautiful Vidamuyarchi team. One, yeah. So every day at 6 PM நாங்கள் வந்து கிளாஸ் எடுப்போம். இன்றைக்கி வந்து 7 PM ஆயிடுச்சு, பட் ஸ்டில் ஈவினிங். அண்ட் திஸ் எஸ்என்ஜி ஆப் இருக்குது, டூ செக் இட் அவுட். அதில் வந்து யூ ஹாவ் கொஷின்ஸ் சாப்டர் வைஸ், யூனிட் வைஸ் அண்ட் கிராண்டஸ் அஸ் வெல். Okay, fine. You have daily MCQs as well, and app access it's just 499. If you have any app related queries also, கேளுங்க in the comments. I will try to rectify it as much as possible. Okay, fine. Because this YouTube platform, I've seen people they just teach live இருந்தாலும் they respond to a few comments. I don't want to be in the mari because once I talk only I have will we have something going on between us, and you'll be able to pay more attention to whatever I say, you'll be able to grasp things better. Okay, fine. Always a teacher student there should be something, some sort of communication always. Okay, uh, I think I've tried my level best இது வரைக்கும். Yeah, so this is my take on wave optics. Okay, this it's a beautiful chapter. Okay, போன class it was ray optics. Ray optics வந்து it was a little weird. நீங்கள் நினச்சிக்கலாம். Okay, because there were so many equations. இதில் வந்து there are just கொஞ்சம் equations, but the concept is pretty uh, say mind boggling. Okay, because இது வரைக்கும் we have seen light travels in a straight line, light moves rectilinear propagation of light we would have studied, but this being in the chapter it considers the wave nature of light. கரெக்டா? ஏன் வேவ் நேச்சர் ஆஃப் லைட் ஃபர்ஸ்ட் வந்துச்சு? Because of, okay, because there are, initially it was particulate nature of light வச்சிருந்தாங்க. This you will learn in dual nature. I'll teach that. Okay, fine. There was theories that light had a particulate nature, and each particle was one photon, and ஒரு photonக்கு ஒரு specific amount of energy தான் இருந்துச்சு. It won't have more or less. இதெல்லாம் you will study. I'll teach you in dual nature. Okay, but then in the chapter we will discuss only about the wave nature, because particulate nature இருக்கிற ஒரு object won't show Young's won't show positive for Young's double slit experiment. Okay, double slit experiment la it will only form when it is a wave. Okay, fine. So does for diffraction and indifference. Okay, sorry, diffraction, constructive interference and destructive interference, and also your Doppler's effect. Everything, it depends upon frequency only. Okay, frequency and wave nature of light, not the particle nature. Okay, fine. இது வரையும் கிளியர் நினைக்கிறேன். Okay, so a wave is a disturbance in a medium. Okay, a disturbance, basically a disturbance. இப்போ நீங்கள் தண்ணியில் if you drop a pebble, it will form a disturbance which will propagate in this manner. Correcta? Fine. Even there, when I drop a pebble here in the center, it will form disturbances which will propagate radially. Correct? Yeah. Yes, of course. Everyone in the childhood would have done this, right? Okay. This is your wave. This is a wave. Okay. இங்க பாத்தீங்கன்னா I'll come RSA physics last 30 days எப்படி revise பண்ணும். I'll come to that in a bit. Okay, fine. every particle in this point, okay, they are in the exact same phase. எல்லாமே பீக்ல இருக்கும். இங்க பாத்தீங்கன்னா it'll ripple, it'll form a wave, இப்படி போகும், and there will be பக்கத்துல இன்னொன்று, there will be பக்கத்துல இன்னொன்று, and this each individual point together they form something called as a wave front. Wave front இது எப்படி டிஃபைன் பண்ணுவாங்கன்னா, இட்ஸ் நத்திங் பட் a locus of all points in same phase. Correct? Understood? Fine. Locus of all particles in a same phase is what a wavefront is. All right, fine. Paka. So far, this is basic of whatever we are supposed to know. இந்த மாதிரி இருக்கும். Well, I could show you a simulation. நான் Young's double slit I have a few simulations for you to make it understand. Okay, fine. Bro, can we expect theory questions like statement bro in physics? If so, how many questions do we expect? In which chapter they come? I can't predict all that. Okay, I'm really sorry. Questions வரலாம் கண்டிப்பாக. ஸ்டேட்மெண்ட் கொஷின்ஸ் யூ கான்ட் ஆஸ்க் நியூமெரிக்கல்ஸ் ஃபுல்லாகவே. ஓகே, ஸ்டேட்மெண்ட் கொஷின்ஸ் கண்டிப்பாக இருக்கும். யூல் ஹேவ் அசர்ஷன் ரீசனிங் அதுக்கப்புறம் அதான் சூஸ் தி ஹவு மெனி நம்பர் ஆஃப் ஸ்டேட்மெண்ட்ஸ், எவ்வளோ இதில் எத்தனை ரைட்டு, ஹவு மெனி ஆர் ராங், விச் ஆர் நாட் ரைட், விச் ஆர் நாட் ராங், அந்த மாதிரிலாம் கொஞ்சம் ட்விஸ்ட் பண்ணிலாம் கேட்பாங்க. ஸோ டோன்ட் வரி, கொஷின்ஸ் வரும். ஐ கான் மோஸ்ட்லி தியரி பேஸ்ட் கொஷின்ஸ் வில் it's yeah, அது அப்படி சொல்ல முடியாது. questions will be there. Okay, yeah, fine. I can't predict all that, Mano. Fine. Okay, now if a source were a point source, okay, if my source was a point, okay, ஒரு பாயிண்ட்ல ரிப்பல் இருந்துச்சுன்னா it forms wave front. Okay, its disturbance spreads as a sphere. Okay, ஒரு say இப்போ this is a part of sphere. Okay, இதுக்கப்புறம் உள்ள this is on the from the topல இருந்து water surface you are looking it at, but then when you go under the water, okay, but still there will be waves which move from the center radially outwards. Okay, and they together form a sphere. Okay, simple. Now if it were linear source of disturbance now, they'll form a cylinder. The wavefronts form cylinder they'll form. Okay, fine. Paka. All right, I think so far it's clear. The session will go like finishing all the concepts first, and then I have PYQs. I'll get over. Okay, fine. So far it's I think it's clear. There are few points you need to know. This is சொல்லிட்டேன். Wavefront is the locus of all points in the same phase. Fine. Okay, another point, direction of propagation of a wave is perpendicular to its wavefront. Well, it's very obvious. Now direction wave இப்படி போகுது, wavefront is இப்படி இந்த மாதிரி, so it's definitely perpendicular, right? பக்கா. And then whatever speed it goes, it's called as the speed of the wave. Now அது அவசியம் இல்லை, but still these are the 2 points you need to know. enlarge it a little bit. And I hope that you all know what phase is. Okay, now I discussed the exact same term in oscillations, waves. Where is discuss பண்ணேன்? Yeah, EM waves discuss பண்ணேன். Okay, so if you want a very good understanding of what phase differences are, do check out my oscillations video. அதில் I had explained it in a really detailed manner. Okay, fine. You can expect 1 or 2 questions from wave chapter. Usually it's directly from the double slit experiment. Okay, fine, don't worry. Okay, Huygens principle. Sorry, excuse me. Okay, now this guy called Huygens, what he did, he was like, okay, I will try to explain stuffs of light using its wave nature. Okay, he was like, if you see, there is a disturbance. Okay, it will form a wavefront. Wavefront is nothing but a disturbance la இருக்கிற particles in the same exact same phase, right? Okay, so he told, he gave us some few theories that um, this is not a circle but still okay. When it propagates இப்படி, okay, see, fine. When a wave propagates, okay, in the wave front la there are particles இப்படி, fine. A wavefront is nothing but everything in the same phase. Okay, all those locus of all particles in the same phase, fine. இப்போ இந்த wavefrontல இருக்கிற all particles individually they produce waves, fine. This is a primary, they form a primary wave, a primary peak. Individually all these particles they form secondary waves around them. Okay, this is not diagrammatically right, but if you understand. Okay, இருங்க ஒரே நிமிஷம். Okay, fine. Now if you see here, okay, he states that every individual point acts as a point of source and produces secondary wave. Okay, and when the place where all these coincide, okay, the points of all these secondary waves coincide, they form the second wavefront. Paka. Fine, this is my secondary waves. This is my secondary wavelet. Okay, this spherical thing, these form my secondary waves or secondary wavelets, and when இதோட எல்லாமே combine பண்ணும்போது we'll have my secondary wave front. Are you guys clear with this? Okay, confuses now, I can explain it again as well. Okay, fine, thank you. All right, fine, அவ்வளோதான். Okay, So this is what you would see in water. Okay, Huygens in the principle வந்து he emphasized that light also follows the exact same thing. Okay, this is what he his principle were. Okay. Hmm. Okay, now say wave velocity is v. Okay, fine. Now if you see wave வந்து after disturbance it creates a wavefront. Okay, இந்த wavefrontல இருந்து after some time you know its shape. Okay, my say it's a ஒரு awkwardly shaped ஒரு wire and it makes a disturbance in the disturbance வந்து it made a wavefront or a shape. If I know that, okay, at t equal to 0 அதை எடுத்துக்கிட்டேன்னா after some time, okay, அந்த wave front ஓட shape right, it's basically it will be this exact same shape which is gradiates outwards. Okay, fine. So the shape remains same. Okay, now the distance between say or ரெண்டு wave two wave fronts of a time gap of t ன்னு வச்சுக்கோங்களேன். இப்போ இங்கே ஒரு வேவ் ஃப்ரண்ட் இருக்குது அண்ட் தென் இங்கே ஒரு வேவ் ஃப்ரண்ட் இருக்குது. இந்த ரெண்டு வேவ் ஃப்ரண்ட்டுக்கும் ஒரு டைம் கேப் ஆஃப் டெல்டா டி இருக்குது. ஸோ இந்த டைம் கேப்பில் மை வேவ் would have gone through a distance of v del t, right? So this v del t is my distance between those two wavefronts. Simple. This is basic physics. Okay, fine. Okay, all right. Now this exact same game. So I think it's clear so far, right? I'm late. You can always replay this video, okay? Don't worry. Refraction of a plane wave, okay? See, reflection of a plane wave. It all worked till here. Till here, whatever he told was fine, okay? In the mari, this exact wave friends, it'll hit the reflecting surface and then it'll reflect back. So the reflection of light, what was it worked, okay, on his principle. Refraction also worked. Also worked. Okay, so wave இப்படி வருது. Okay, when say in the point it creates a secondary wavelet and அதோட velocity is decreased here. This is refraction. Okay, this is refraction, secondary wavelet. Sorry. Okay, so when this, since it's the medium changes here, okay, this is air and this is water and it's say glass. Okay, glass works. The velocity changes, okay, and it takes a different path. So there is actually bending of light here. Paka. So reflection is proven. Refraction is also proven. What else do you want here? There is a concept called as light emission absorption law. If you see in your atomic structure chapter, okay, chemistry, அதில் வந்து பார்த்தீங்கன்னா லைட் இஸ் அப்சர்வ்ட் as packetsன்னு படிச்சிருப்பீங்க, photons, right? இட் இஸ் நாட் எக்ஸ்பிளைன் பை திஸ். வென் வேவ் ஃபார்மில் இருக்கும்போது அதை வந்து எக்ஸ்பிளைன் பண்ண முடியாது. ஓகே, பட் அதே பேக்கெட் ஆர் பார்ட்டிகிள் ஃபார்மில் ஆஃப் லைட்டை வச்சு we can't explain Young's double slit experiment, diffraction, okay, constructive and diffractive and destructive interference லாம். Okay, we know what interference is. It's just two waves. Okay, அது coincide ஆகும்போது if it constructs or destructs அது பேஸ் பண்ணியிருக்கும், based on their amplitudes and phase differences. Fine, we'll discuss. In the principle, Huygens was like, okay, wave formula தான் போகுது and this is reflection, this is refraction. I am able to explain this, but he was not able to explain what and the continuous emission, absorption of light, and also polarization. He was not able to explain it. Fine. Okay. Okay. Doppler's effect. Okay. Whenever you're in a road, okay, road la வந்து there is an ambulance approaching you. Approach ஆகும்போது you would have heard its sound to be in some frequency, and then as soon as it passes you, the frequency drops down. Okay, and stationary இருக்கும்போது it's at a different frequency. Okay, so basically because of the relative motion between the observer and the source, okay, there is a change in the wavelength and frequency of light, keeping the velocity constant. Okay, this effect is called as Doppler's effect. So இப்போ வந்து just understand this. Okay, I am stationary and source of light is approaching me. Okay, light or theoretical speed limit of this universe, okay, of our universe is 3 is the speed of light. Okay, fine. இப்போ I am say I'm here. Okay, I'm here. There's a light or a star approaching with speed equal to the sound velocity is 338 meters per second, around that in atmosphere, and based on medium it varies. அதே இந்த லைட்டுக்கு வந்து it's constant. Okay, and it's also 3 into 10 power 8. ஸோ அந்த லெவலுக்கு கம்பேரபிள் வெலாசிட்டி இருக்கும்போது தான் வந்து we can actually identify or observe frequency changes and wavelength changes. Okay, just imagine I'm here and the light is approaching me, a star is approaching me. Okay, at some 2 lakh kilometer per second velocity. Okay, yeah, fine. Okay, some say 20,000, some random. Okay, some with some velocity, but it's so high that is comparable to the speed of light. Okay, when it approaches, okay, the light to the velocity is constant. Okay, when it approaches, its frequency increases. Okay, நீங்க கார் வருதுயா, I mean ambulance, when it approaches you, the frequency increases. It becomes higher pitched. Okay, fine. இந்த மாதிரி ஆகும்போது what is higher frequency? What does higher frequency mean? That means the wavelength of the wave is less. Okay, so the wavelength decreases. Okay, when I am observing, say it was yellow. Okay, yellow and it could go to blue because of its higher velocity. Its wavelength decreased. Fine, frequency increased, keeping the velocity of light constant anga. Fine. Okay, this is my Doppler's effect. Okay, okay. Now the change in difference in velocity between the source and the observer this is difference in frequency by actual frequency is equal to minus v by c. Now in the v இருக்கு இல்லையா, v is the velocity of my source. Okay, relative velocity of my source and the observer thing. Fine. C is the speed of light. Okay, fine. இப்போ எப்போ எப்போ வந்தால் வந்து my velocity v is positive. இப்போ பாருங்க, source is here. I mean, this is my star. Okay, star is approaching இப்படி. This is earth. When star is approaching, light is emitted here. Light is emitted. Light velocity is in this direction. Correct? Fine. My star is also going in this velocity, moving in this velocity. So இது ரெண்டுமே இருக்கும்போது shouldn't I add them? Okay, fine. So ரெண்டுமே வரும்போது I should add them, right? அப்போ வந்து my velocity here it becomes, I mean, I should take it as negative, so that this entire thing becomes positive, and the net change in frequency, this sign might be confusing, and the net change in frequency becomes positive. Okay, when it moves away, so here positive, I mean, we taken as negative since frequency increased, right? Okay, now if it were to move away, light will be wrong. This is my earth. V is taken as positive, so that there is a decrease in frequency. Decrease in frequency, increase in wavelength. Exact. Okay. Fuck up. Yeah. I hope this makes sense. Yeah. Okay. Fine. Now it's 7:45. I'll take a break till 7:55. Okay. Class will resume at 7:55. இன்னும் ரெண்டு டாபிக் தான், we'll finish it. Okay. Okay. See you guys. check. Yeah. One question. Let's start with a question. Okay. Light, a star. Okay, star is moving. Okay, we don't know if it's moving away or it's moving towards Earth. Okay, fine. The spectrum of light, it shifts towards violet. Shifts towards violet. Now tell me, violet direction, is the star moving closer to me or is it moving away from me? Okay, fine. When it's violet, so violet இருக்கும்போது no response obviously. Okay, நானே சொல்றேன். When it's violet, okay, violet, you know, it starts with gamma rays, UV rays, okay, ultraviolet rays இருந்து it comes to the visible spectrum through this. Okay, so violet நாலே it's of higher frequency and shorter wavelength. Okay, fine. So இப்போ வந்து it's shifting towards that na wavelength is decreasing. When wavelength is decreasing and or frequency is increasing, is it approaching me or is it moving away? It's approaching me. அதனால தான் வந்து frequency increase ஆகுது. கரெக்டா? Fine. Okay. அதான் வந்து if you see um, இப்போ ப்ரிசம்லாம் பார்த்தீங்கன்னா prism red will have least deviation, whereas so maximum இது வந்து சும்மா ரெப்ரசன்டேஷனுக்கு ஓகே ஃபைன். இங்கே கூட நீங்கள் பார்த்தீங்கன்னா the spectrum, okay, fine. Okay, this is not right, still okay, fine. Ignore this, இதுக்கு மேலே just ignore it, okay. ஆனால் இங்கே வரைக்கும் பார்த்தீங்கன்னா it starts with red, orange, yellow, green and blue, indigo, violet. Okay, this is your spectrum of visible light. Okay, fine. இந்த ஸ்பெக்ட்ரமில் தான் வந்து இந்த ரெட் பார்த்தீங்கன்னா இட் ஹேஸ் லெஸ்ஸர் வேவ் ஐ மீன் ஹையர் வேவ் லென்த். ஓகே, அதே வந்து இஃப் யூ சி போக போக கீழே போக போக the wavelength decreases and the frequency increases here. Fine. Okay, because red has maximum wavelength, more it shows minimum deviation. Fine. Okay. Okay, now sources of waves la there are there's a concept called as coherent sources and non-coherent sources. Okay, coherent sources and non-coherent sources. How do I define coherent and non-coherent sources? Visual represent பண்ணனும்னா my coherent sources will be say இந்த மாதிரி. Okay, பக்காவா in faceல அப்படி இருக்கும். This is an example of my coherent source. Fine, okay. Then incoherent sources it will be like this, or non-coherent sources. Random say this is the source of light, okay, the source. This is not a source, this is not a source. Fine, okay. Random அப்படியே இப்படி இருக்கும். Fine, okay. Now, how do I define a coherent light? Okay, இதுல the electromagnetic wave. Okay, light is not particle. Light does not have any does not require any medium to flow. It's an electromagnetic wave. We know that. EMF if okay. This wave all the individual this source of light all the individual waves or a frequency they are identical. Their phases are the same or constant. Okay, exact ஒரே phase இருக்கு. And this relationship of a constant phase it goes on, okay, a constant phase with identical frequency is what are coherent sources. Laser light laser light is an example. We used to play with it. Okay, laser light is a constant, means a coherent source of light. நீங்க பாத்தீங்கன்னா these waves, they are, can I call them synchronized? Since they are synchronized, they are able to travel a lot longer. So is my pointer laser light. Okay, my laser light, it travels a lot longer than a normal torch light, correct? Because the source of lighting and it's coherent. Fine, when it's coherent, it's usually very much localized to a single point. Laser light, obviously everything laser light, a single point there. Fine, okay. So we use, so everything basically in a room looking lights in front. I have a light here. Everything, the light spreads everywhere. Okay, it's not the same as coherent. So it's everything whatever we have used as a daily appliance, they are non-coherent light. Okay, fine, okay, fine. Addition, superposition of waves. When I superpose waves, okay, superposition of waves is nothing but superimposing. Okay, superimposing is also a little, okay, ஒரு வேவ் இருக்கு அண்ட் என்னோட வேவ் இருக்கு, ரெண்டையும் நான் சேர்க்குறேன். ஃபைன், basically what would happen now, there could be an increase in amplitude, okay, or there could be a decrease in amplitude. The maximum increase in amplitude will be equal to the sum of individual amplitudes, and the maximum decrease in amplitude will be the difference of these two amplitudes. Fine. Okay. Is this waves chapter நம்ம பார்த்தாச்சு. I don't have to go in detail. நான் வந்து உங்களுக்கு formula மட்டும் I'll discuss here. Okay. Fine. It goes like A, this is amplitude of the resultant wave, okay, is equal to root over a1 square plus a2 square plus 2a1 a2 cos phi. Okay, phi is nothing but phase difference. What is phase difference? What is phase difference? Come on, anybody in the comments tell one liner, like if you explain me what phase difference is. One liner la what phase difference is, tell me, and then we'll proceed. அதுக்கு முன்னாடி I'll get into the next one. So this is amplitude, அதே வந்து intensity எழுதுனா intensity of the resultant is equal to intensity of first wave plus intensity of second wave plus 2 into root over I intensity of first wave intensity of second wave cos phi. This is all I need to know for superimposition of waves. Paka? Okay, fine. Ipo, when will they have an increase in the entire thing now? Okay, this is my over wave. Okay, my other wave is exactly இப்படி, அதாவது the crest matches the crest, the trough matches the trough. Okay, so it's in the same phase, ஒரே phase இருக்கு. Still I didn't receive any one liner of what a phase difference is, guys, come on. Okay, so they're in exact same phase. Okay, ஒரே phaseல இருக்கும்போது the resultant wave will have a higher amplitude than that of the other two waves. Correct? Paka. This is when it is equal to a1 plus a2 directly. Yeah. Yeah, but it's negative. Yeah, but it decreases now. See this wave. Fine. Okay, I'm sorry. I'll rewrite it again. So ஒரு wave இருக்கு. This wave and the other wave கீழே இருக்குது. இந்த மாதிரி இருந்துச்சுன்னா, see here, இங்க வந்து the crest of one coincides with the trough of the other. Crest of one coincides with trough of the other. So basically இந்த மாதிரி இருக்கும்போது I'll have a smaller wave amplitude. Fine. Okay, and then இங்க தான் வந்து my phi will be equal to what? Cos phi will be equal to 0. No, cos phi will be equal to -1. Appo it'll have a decrease. So if it's -1, cos phi is nothing but it goes from 0, it goes from 1. It's 180 degrees of difference. No, it's 270 degrees of difference. Okay, right. Because cos goes like in the mari. This will be my 90, 0, 90, -1 is 180 now. 180 degrees. Okay, so yeah, this is what it is all about. Okay, fine. Okay. Hmm. When can I call a wave a source of wave? Okay, two source of wave. Okay, inga vande it's a single source. Okay, now I'm having two sources, two source of wave. Two sources are coherent. நான் எப்போ சொல்லுவேன் when they produce waves of the same frequency of the same frequency and what else ஒரே frequency இருக்கணும் and then the phase should be the same frequency and phase. Fine. Okay, ஒரே frequency ஒரே phase. Yeah, அவ்வளோதான். Just give me a second. I'll drink some water. So yeah, யாருமே how much are you enjoying this class? It's been, is it boring? இல்லை எப்படி போயிட்டு இருக்கு? Yeah, in the notes if you want now it will be uploaded in the app. If you want, go check it out. Okay, fine. Okay, so sources are coherent if the frequency in this is the same. Okay, fine. Okay, this is called as interference of light. Okay, this is my interference. ஒண்ணுமே இல்ல, the name says everything. Okay, about whatever this is. Two individual waves, they are interfering with their paths. My interference appo my law of conservation of energy, it holds good. Obviously law of conservation of energy holds good for everything. Okay, and then what happens here, my very important point in the case lab, my energy is redistributed. Okay, fine. Just give me a minute. Ipo yeah, fine. Let's see slits. Okay, fine. Okay, this is what happens through one slit. Okay, this is my Young's double slit. What he did was light வந்து I'll tell you, we have seen objects, okay, we have seen objects casting shadows because of light, okay. So whenever light hits those objects, okay, whenever I'm irradiating it with light, it forms shadow, okay, and the shadow resembles my object, okay, exactly, it resembles my object, fine, it resembles my object, okay. But when it's small enough, when this is small enough, okay, when the object is small enough, my light bends around. இதனால தான் வந்து we are not able to see atoms at all, okay, through light, using light. Electron microscope வச்சு பார்க்க முடியும், but still you can't use an electron microscope to have a clear view about the subatomic particles, because electron microscopy la it's small, okay, wavelength of electron is small, so electron which we are finding the we are able to see stuff, okay. When it's subatomic, okay, it has its size is even smaller than the wavelength of electron, so it won't even hit it, okay, right. I hope it makes sense. Right. So back to our simulation here, okay. So if you see here, this is my water wave generator, okay. தண்ணில நீங்க ட்ரை பண்ணி பார்க்கலாம், and have two slits இப்படி. இங்க பாத்தீங்கன்னா after my wave hit the slits, okay, after it hit the slits, the points on the slit, it started to behave as a point source. Here it is a linear source, okay, linear source இப்படி வருது, okay. But after it hits the slit and the point, it becomes a point source. Obviously Huygens was right about the secondary wavelets and stuff. So இங்க பாருங்களேன், see, it comes, hits it, and when it hits the slit width correctlama, see here, it acts as multiple points of small primary sources or secondary sources in this case, and then they form this amazing beautiful pattern on this water. By the way, you can see there are peaks in the center, there are peaks in the top, there are sides where there is no wave, anga. This is my double slit experiment, okay. I'll show you diffraction as well. Let's take a wavelength of 480 nanometer, okay, fine. Diffraction slit is yeah, or chinna idu, okay. This is how diffraction looks, okay. It's a square, it looks இப்படி. You have okay, diffraction போறதுக்கு முன்னாடி let's finish interference and come here. Young's double slit experiment and we will do, okay, fine. So basically இங்க பாத்தீங்கன்னா diffractionல you can see light, okay. This is what we expected was for light to be a particle when it goes through this hole, and the hole மட்டும் தான் illuminate ஆகும். Obviously that's what we expect for, as far as I have seen. நான் சின்ன வயசுல இருந்து பார்க்கும்போது, say this is a remote, it casts a shadow here, okay. The shadow it casts is sharp enough, and then it forms only the size of the image, அது அந்த edges இருக்கட்டும், it's all perfect. But இங்க பாத்தீங்கன்னா it goes beyond it, okay, and it forms these patterns, these beautiful patterns. You can see the dot stuff here, You can appreciate that, right? Fine. This is my diffraction. This is my okay. This is a simple way of experimenting my Young's double slit experiment. Okay. Okay. Basically, two point sources of disturbances forming the exact same pattern. Pathingla. They form the exact same pattern. So what did I tell you? After it hits the slit, those points, okay, on the slit, those gaps, they behave as a point source. So what is the exact same thing? Okay, just see here, see here, the exact same thing. Fine, paka. I hope this is. I'm emphasizing more on this topic because it's important. This is what they are obviously they're gonna ask questions. So yeah, fine. Now what all you need, what all you know, you are supposed to know on this topic. In the topic la, it's very simple now. Okay, ஒன்றும் இல்லை simple. Okay, say என்னோட slit இருக்கு, என்னோட source இருக்கு, light source. Okay, I can't draw it here. Okay, fine. Nice. Slit இருக்கு. Okay. This is my source of light. Okay, fine. After it goes here, it forms patterns in the மாதிரி. It forms wavelets. Okay, fine. And then they form few structures. That was for water. Okay, this is for my light. It forms a bright spot, a dark spot, a dark spot, and a bright spot, and a dark spot, and a bright spot, and a dark spot. Okay, fine. Okay, the every side of yellow here is a resultant of constructive interference. And every point here, the dark thing, is because of destructive interference. Fine, constructive and destructive interference. What is constructive? What is destructive? We saw it here. Yeah. Basically, this is what it is. Yeah. Yeah. Constructive, the amplitude increases. Fine. You get brighter spots. Destructive, the amplitude decreases. Fine. And it's totally dark. What do you mean it decreases? Because they are exactly the same. They just cancel out each other. And then you have completely dark spots. Fine. Okay. All right. Now, the diagram is a little bad, but still, okay. Hmm. Hmm. There is a central maximum, and then followed by two dark sides, and then a maximum and a dark side. And as we progress, we can see that in the patterns, the alternating bands. Okay, dark, light, dark, light, dark, light. This is my. This is my. This is my Young's double slit experiment oda observation on the black screening, correct? Alternating light dark bands. Fine. This is what I tried to draw it here as well, and it didn't come out well. Fine. Okay. Okay, fine. So where were we? Fine. Now the distance between any two dark bands here, there any dark band irukku illaya, the distance between them two is beta or fringe width, over fringe width. Fine. Okay. Now this distance between two slits is taken as small d. Okay. And the distance between the screen and the slit is taken as capital D. Okay. Okay. Fine. Now this fringe with irukku, fringe with beta. It's equal to lambda capital D by small d. It has derivations. I don't think it's required hippo. Okay. Fine. Fine. What else? Theta. Theta is the angle. Okay. Now let's take a different color. Either green, something darker too. Okay. This works. Now look at this line. The angle made by this point here. From the central maximum. This is my central maximum. Okay. This is my central maximum. The point mala somewhere, it makes an angle theta. Okay. This angle of theta is nothing but y by d. Theta is equal to y by d. Because it's nothing but tan theta, but still tan theta is comparable to theta when theta is small enough. Okay. And in the mari, for light to exhibit Young's double slit experiment in the mari பார்க்கறதுக்கு, we must have very small slit sizes. அப்பதான் வந்து we'll be able to observe all these patterns. Okay, fine. So my theta is equal to y by d. Fine. Okay. Now I'll give you a question. Answer the as fast as possible in the chat. I'll dictate it now. Say I have a screen. Okay, screen distance is capital D, which is at a distance of 2 meters from the source. Okay, slides are emitted with a light of wavelength 600 nanometers. Okay, fine. Now the slit width எனக்கு தெரியல. Okay, slit width தெரியல. Slit width means the distance between two slits. எனக்கு தெரியல. Fine. Okay. தெரியல. I know the fifth maximum. அதாவது in these patterns, right? The question which you'll be able to understand. The maximum is nothing but the brighter spot. Okay, wow. In the brighter spot, it's here, and அதுக்கு மேல போக it goes on decreasing, but still in the மாதிரி bright spot, and this the one above, just above it, is the second maxima. அதுக்கு மேல போனா is the third maxima. அதுக்கு மேல போனா is the fourth maxima. Fine. I think இப்போ ஒழுங்கா தெரியும்ட்டு. fine. The first maxima, second maxima, third maxima, and the mari. That's your okay. This is what it is. So fifth maximum is at a distance of 0.005 meters from the central maxima. Okay, so he gave me y. Y is nothing but the height from the central maxima. Okay, fine. Okay, now I'm supposed to find small d. Okay, அதாவது the slit ரெண்டு ஸ்லிட்க்கு நடுவுல distance. Fine. What is one fringe width? ஒரு fringe width நான் தாண்டேன்னு வச்சுக்கோங்களேன். From one ஒரு fringe width தாண்டேன்னா I'll get to the other. அந்த மாதிரி 5 fringe width தாண்டினா தான் I'll get to my fifth. Okay, I get to my fifth thing. Okay, this fringe width is nothing but for individual or small beta or fringe width, and 5 times of fringe width is the distance distance at where I can find my fifth. What is fifth maximum? Fine. So can I write it as 5 into beta, right? 5 into beta. Beta, this is my fringe width, will be equal to my lambda capital D by small d. Fine. The exact equation நான் அப்படியே இங்கே எழுதிட்டேன். But 5 beta, because 5 beta na, yeah, 5 beta because in the distance இருக்கு இல்லையா. Now see, this is central maximum. Central maximum இருந்து ஒரு fringe width தள்ளி, okay, I think I wrote it wrong. Half fringe width தாண்டி, okay, பாதி fringe widthல you have second, இன்னொரு பாதியில் you have third, so it's 5 into lambda by 2. Okay, 5 into beta by 2. I think this equation works. In the equation யாரும் புரியலன்னா just let me know. இதுக்கப்புறம் diffraction and we'll go away. Okay, thank you so much Divakar. Kalai Selvan, if you don't like it, just watch, just go away. வேற ஏதாவது சேனல்ல போய் பாருங்க. Yeah, okay. And yeah, I'm trying to be better. இன்னைக்கு I don't feel well at all. உடம்பு சரியில்லை. I had an exam காலையில, but still okay, it doesn't count. Okay, fine. I'll try to be better. Okay, fine. So now this is what it is. Beta is my fringe width. Okay, fine. And this thing is equal to what? அவன் கொடுத்துட்டாங்க. This is equal to 0.005 meters into. அப்போனா I have to directly equate it here. Fine, அவ்வளோதான். Lambda is nothing but 600 nanometers. That's 600 into 10 power minus 9 meters into distance between the slit and the screen. What is that? That's 2 meters. Fine. So into 2 meters divided by distance between those slits, which is what I'm supposed to find. அது எனக்கு தெரியல, அதான் கண்டுபிடிக்கணும். Is equal to 0.005 meters, and if you solve it, your answer will be 0.0, okay, 5 into 10 power minus 2 5, 3, 10 power minus 3. Fine, okay. 0 D. This is 10 power minus 6. Okay, and 5 will become 12. 12 into, so 24 into 10 power minus 6 meters, or 24 micrometers is the slit distance. இந்த ஒரு question வச்சு I think I've covered so much okay of this entire concept. Fine. If it were okay, fine. So and slit width which I mean fringe width, yeah, fringe width which we can find where I'm having my next maximum. So after every half of a fringe width I'll have a maximum. Okay, so basic ரெண்டு black நடுவில் இருக்கிற கேப் வந்து ஒரு fringe width அப்போது அந்த ஒரு பிளாக்குக்கும் நெக்ஸ்ட் சக்ஸசிவாக இருக்கிற ஒரு yellowக்கும் fringe width beta by 2 the distance. Fine. So அதை வச்சு I am equating it here. Fine. This is, but it's not necessary, but this is what I wanted you to know. Okay, I wanted you guys to know this one. Fine. Okay, paka. Thank you, Divakar. Understood now. Okay. Okay. Fine. Now diffraction. Let's see what diffraction is. Card not here, but still this is what it looks. Okay. Yeah, it's all these beautiful patterns when you have anything. See these stuff. This is called as diffraction. Okay. Either intensity, it goes on decreasing. This is a single slit diffraction. Okay, fine. It form அதாவது அதில் வந்து we had two individual sources of light interact பண்ணுற மாதிரி, and then there was proper interference and proper constructive and destructive interference. Here we have only one slit. Okay, ஒரு ஸ்லிட்ல இருக்கிற ஒரு ஸ்லிட்லேருந்து வர waves they interact constructively, they interact destructively as well, but still to some extent தான் அதை பண்ண முடியும். அதனால் it goes on fading away. இங்கே நீங்கள் பார்த்தீங்கன்னா the image, this is the central maximum, it is peak. Okay, அதுக்கு அடுத்து the intensity has changed. When you see in here, okay, Young's double slit, it doesn't change அவ்வளோக்கு, but here you can see proper change in intensity, and then the distance between them is also varying. Okay, fine. Okay, it requires one more equation, ஒரே ஒரு equation. அதுக்கப்புறம் we'll solve questions and we'll leave. அதுக்கப்புறம் polarization base பண்ணி I'll teach that in your dual nature lab about polarization and all that. So if you don't worry. Okay, fine. Anna, everything is fine. You're teaching. Okay, Harshini. Fine. Yeah, I'll try to be louder. I just don't feel okay well today. Okay, fine. So single slit diffraction, it's pretty simple. So double slit பார்த்தோம், that's where it was our Young's thing. Single slit, okay, it forms on the screen. Okay, fine. The thing you have to know, you're supposed to know is this, say the slit width. இங்கே தான் வந்து the concept of slit width comes. Okay, this is A. Fine. And say and the patterns we saw, the exact same patterns. The exact same patterns which we saw anga, it was like we had a peak, we had a dip, we had a peak, we had a dip, exact same thing. Fine, we'll discuss how we are supposed to approach it. இதுக்கப்புறம் we'll solve questions and we'll finish it off. Fine. Okay, so there's a peak here. There's a beautiful peak here. Okay, that's bad. There's a peak here. Fine. And there's a peak again here. There's a peak again here. But intensity still changes. Okay. There is complete darkness here. There's complete darkness between them. Fine. Okay. Condition, where will I find okay, fine. Okay, before that, this is the distance between my slit and the screen, and இந்த ஸ்லிட்ல இருந்து ஒரு ஆங்கிள் எடுத்து நான் இதோட மேக்ஸிமா, ஓகேவா? இந்த மேக்ஸிமா ஒரு ஆங்கிள் இருக்கு. ஓகே, ஒரு ஆங்கிள் இருக்கு. ஃபைன், திஸ் இஸ் வாட் யூ ஆர் சப்போஸ் டு நோ. இங்கே the maximum height is at some angle. Okay, fine. And that maxima, okay, a sin theta, the sine of this theta is equal to odd number divided by 2 into lambda. Okay, for that maxima condition, this is the condition for maxima. Then helping you understand why this formula came, I'll explain you how to apply it so that you won't forget it. I have questions too, don't worry. Okay, fine. அதே வந்து for minima it is a sin theta is equal to n lambda. So yeah, fine. Okay, when you see a graph of intensity அந்த simulation கொஞ்சம் மறந்துடுங்க. அதில் வந்து யங்ஸ் டபுள் ஸ்லிட் எக்ஸ்பெரிமெண்ட்லேயும் வந்து தேவர் intensity changes, but yeah, obviously it happens, but still when they ask you in exam, say YDSC Young's double slit experiment, other intensity, it's like this: a peak, and it drops, a peak, and it drops, a peak, and it drops. The peaks are the same level. Okay, fine, the peaks are the same level and the distribution is also uniform. Okay, now it's going. அதே வந்து if it I mean in this case, okay, YDSC இல்லாம, this is single slit diffraction, it is peak and then dips, and then there's a smaller peak, and then there's a even smaller peak, and then it goes down. Okay, there's a smaller peak and then there's a smaller peak, and it just goes on. Okay, it just fades away. Fine, this is what happens. In the simulation it was clearly represented, showing that either intensity we can obviously see that the upper ones are little less brighter than the middle one, but the intensities are same as per your NCRT or as per your NEET exam is concerned. Okay, for statement based questions, when they ask from this one, don't I mean, you can imagine using that அந்த எல்லாமே அந்த simulation itself, but still don't forget this one. Okay, the change in the intensity. Okay, fine. All right, now we'll solve a few questions. I think அதுக்கப்புறம் it'll get better for you to understand about whatever single slit diffraction is. Okay, fine. Okay, this is a previous question, CBSE APMT. Fine, we have a monochromatic light of wavelength lambda. This is a diffraction question. Monochrome light of wavelength lambda வந்து hit ஆகுது. Okay, lambda, wavelength lambda. Fine. It produces a single okay, obviously single slit diffraction பத்தி தான் பேசிட்டு இருக்கோம். Fine, SSD. Okay, it forms a pattern. Okay, if D is the distance between the screen, D, capital D தான் represent பண்ணுவாங்க usually, distance between screen and slit. Fine. The width of the central maxima will be the width of central maxima will be is what they're asking. Fine. Okay. So basically the question goes like, you're having a wavelength of lambda light hitting a single slit diffraction, single slit doing undergoing this single slit diffraction thing, and then it's hitting a screen and he's asking me the width of the central maxima. Okay, this it's very simple, very personal. Okay, so you have the screen, you have my source or the slitting kuttiya irukku, and then this is the distance. In the distance between those two are capital D. அதுக்கப்புறம் என்னோட yeah அவ்வளோதான் capital D. Now இந்த ஸ்லிட்டோட width இருக்கு இல்லையா, this is capital small a, and then this is my angle theta. There's a small concept inga you have to understand before getting into questions. Okay, why doesn't it move? Okay, it's moving. Okay, fine. Fine. This angle is your theta. This is my theta. Okay. When you see a central maxima, it has a center point. Okay, and then it goes down and goes upward as well. In the theta, it includes only one half of my central maxima. The other half is down. Okay. I can't invert it. It's so sad. Okay, the other one is here. Fine. Okay, so when I find slit width na theta வச்சு கண்டுபிடிக்கும் போது வெறும் பாதி தான் கண்டுபிடிப்பேன். The remaining half I have to find it by multiplying it with 2. Simple. Basic maths. Okay, fine. Where do I my formulas here? For maximum it was a sine lambda by 2. Fine. A sine theta was equal to my lambda by 2. A is nothing but my slit width. Sine theta is nothing but, okay, a sine theta is equal to lambda by 2. This is my first maximum. I mean central maximum. Fine. Okay. Now, can I write theta is equal to this height as y, okay, and this as d, sine theta opposite by higher. I don't know. Wait. Can I write it that way? Can I write it in that way? Can I write it as y by d in the case? Let me know. It's little confusing. Okay. என்ன பிரச்சனைனா, when you take it in that way, for theta, for small angles, I can write sine as I can compare it to tan, and I can compare tan theta as y by d. So a into y divided by d, because this applies only for small angles. Fine. Okay, is equal to my lambda by 2. Okay, fine. இப்போ y தான் நான் கண்டுபிடிக்கணும். Y is equal to d lambda by 2a. ஓகே, இது வந்து ஒரு ஹைட் ஃப்ரம் த சென்டர்லேருந்து, இது வந்து y ஹைட் இருக்கு. ஸோ சென்டர் கீழே எவ்வளோ ஹைட் இருக்கு? another y height. So 2y is my width. 2y is equal to 2 into d lambda by 2a. So d lambda by a is my width of central maxima. Correct? Okay, fine. We have another question. I have all the PVQs from this chapter. Okay. Hmm. A beam of light, same. Usually in the chapter, the only thing they ask is from very very common diffraction SSD and YDSC, young double slit experiment. All the in the ரெண்டு கான்செப்ட்ல இருந்து questions are maximum. Huygens principle you just know how it is. Okay, fine. Hmm. The concept of diffraction there is something called as path difference. Okay, path difference இருக்கிறதால தான் வந்து there is a change in phase-னால தான் வந்து there is a change in there are interactions இந்த மாதிரி. That path difference, okay, when you take I'll try to draw it here. Okay, இப்படி fine. Okay, a wave. Them reaching the exact same point. Okay, the upper one actually reaches first, correct, than the lower one. ஏன்னா அதோட path அப்படி இருக்கு. Fine. So there is a difference in the path. Okay, actually speaking, that path difference, my delta L is equal to d sine of theta. What is sine theta again? This angle theta of where they are going to meet, which I think y by d. So my path difference of del L is equal to d into y by d. Okay, based on the path difference தான் வந்து I am having particular thing. If the path difference we know if it were lambda by 2 na, phase difference equal to k into path difference. Okay, இந்த கான்செப்ட் புரிஞ்சுக்கோங்க. phase difference is equal to k into path difference. Okay, k is nothing but 2 pi by lambda into my path difference. If it were lambda by 2 na, the phase difference will be pi, correct? For pi phase difference na ஒன்று இப்படி ஆரம்பிச்சிருக்கோம். this entire thing is pi. Okay, this is 90 degrees and this is 90 degrees again. So ஒரு wave தள்ளி it had joined again. It had joined after one wave. So this is for if it were lambda by 2 or a multiple. So ஒரு wave தள்ளி it had joined na, என்னோட wave இங்கே இருக்கும்போது the other wave was here. Okay, this was the first wave now, the other wave was here. Okay, so it was here. அப்போ என்ன ஆகும், when you continue this wave it goes again இந்த மாதிரி. So you can observe that it's constructively interfering. Fine. If in the case of iPhone, bro, it doesn't go away. Okay, fine. Mac. Okay, fine. அதே வந்து take it as lambda in the multiples of wavelength. அப்போ என்ன இருக்கும், if it will be in the it will be 2 pi. 2 pi is something like 360 degrees. Appo it's still fine. Okay, and then it goes again, it becomes 3 lambda by 2 அந்த மாதிரினா ஓகே டிஃபரன்ஸ் அப்போவெல்லாம் வந்து there is constructive interference. That's the exact thing I told you here. Fine, paka. All right. One more question. The question was when they ask the exact same question இருக்கு இல்லையா, this was asked in 2015 and this question was asked in 2014. Exact same question, okay. ஏன்னா என்ன கேட்டாங்க, here we are supposed to find the width of the central maximum. And the 2014 question என்னன்னா, they were asking the distance between the two dark fringes of the opposite sides in the two extremities. The first dark fringe of two extremities only error gap இருக்கு, which is nothing but that width of the central maxima. Pakka. So basically they repeated the exact same question twice. I wanted you to know this. Okay, fine. All right. Okay. So yeah, I think idu vachi you can solve questions for say YDSC and diffraction. Almost all the topics are over. A diffraction pattern due to a single slit. Okay, first maximum was observed at an angle of 30 degrees diffraction angle. Okay, fine. Wavelength வந்து 500 amps 5000 angstroms. Okay, first this is my first minimum. First minimum அங்க இருந்துச்சு. Now we are supposed to find first secondary maximum எங்க இருக்குன்ட்டு. First secondary maximum ஓட angle. Okay, fine. We know A sin theta is equal to n lambda for minimum. For minima. Yeah, minima video வரும். We just saw if it were lambda by 2 na, it becomes the multiple of pi 2 pi, and then it's nothing but an entire wave was lagging. அப்படி இருக்கும்போது they just constructively interfere. But if it weren't that case, they destructively interfere. Okay, this is the condition for minima. Okay, fine. So A வந்து நமக்கு தெரியல, sin 30 is 1 by 2 is equal to first minima lambda is 5000 into 10 power minus 10 meters. Okay, so this is nothing but A is equal to 10 power minus 6 meters. So 10 power minus 6 meters கிடைச்சிருச்சு. This is my A value. Fine. இப்போ இந்த A value வச்சு we are going to find the what were we supposed to find? Secondary maximum. First secondary maximum எங்க இருக்குன்ட்டு. Okay, primary maxima, central maxima, அதுக்கப்புறம் there is a secondary maximum in diffraction. Obviously the secondary maximum ஓட angle கண்டுபிடிக்கணும். Okay, அதுக்கு வந்து it's A sin theta is equal to, what is the formula? It's lambda by 2 into 1. Fine, correct? Lambda by 2 into 1 வரும். 1 is for the central maxima. So it will be 2 here. I mean it will be 3 here. 3 lambda by 2. Fine. So sin theta கண்டுபிடிக்கணும். A is nothing but 10 power minus 6. Sin theta is equal to 10 power minus 10 into 5,000 divided by 2 into 3 into A is nothing but 10 power minus 6. It becomes 10 power minus 4. 0.5, 1 by 4. So 3 by 4. Sine inverse of 3 by 4 is my theta. Fine. Okay, clear. There you go. My sound my maximum there, but still okay. Fine. Okay. So this is my first secondary maxima. Now one more concept here. Okay. Here secondary maxima. அதாவது my this thing. This is my நடுவில் இருக்கிறது primary. அதுக்கு மேலே இருக்கிற secondary. That's my first secondary maxima. And then this is my second secondary maxima. அப்படியே போயிட்டு இருக்கும். First secondary maxima வரக்கு I am using this is formula. It goes like first now 1 plus 2, it becomes odd, and then this is 2 now it has a wavelength difference of 5 lambda by 2. Okay, and then it becomes 7 lambda by 2. So 0 mean lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2 அந்த மாதிரி ஒரு progressionல the wavelength difference between what the path difference varies. Okay, this distance it varies. Other there is a phase difference change, or not this one. Other there is a phase difference change. Because of the phase difference change, they constructively or destructively interfere. Yeah, fine. Okay, so this is basically what entire wave optics is about. It's a very simple chapter. The only two things you have to focus is in the YDSC and diffraction. I think I've explained you, because no I'll repeat to you once again. Diffraction la, okay, you have similar patterns to that of your YDSC, but in diffraction its intensity gradually decreases. Okay, point number 1. Point number 2, for diffraction of one and diffraction LU and that of YDSC LU, the path difference, okay, for interaction for constructive and destructive interferences, the path difference remains the same. Fine. Constructive, it should be an odd multiple of lambda by 2. Okay, you must have an extra lambda by 2 with you, so that உன்னோட அந்த 2 pi ஓட கீழே 2 will get cancelled. அப்போ தான் உன்னோட phase will be in such a way that it just lags behind an entire wave, not half or quarter wave. Fine. Okay, so my central maxima it's just lambda by 2, and then for everything else it's add another lambda. So lambda by 2, 3 lambda by 2, 5 lambda by 2, and it goes on. Okay, this is exact thing, say applies for both diffraction and and YDSC. Where is YDSC? Yeah, this odd lambda by 2 is nothing but if it were 1, okay, if it were 2 it's nothing but 3. If it were, it's just adding lambda by 2 plus the plus lambda for every maxima you are going through. See, this is secondary maximum. Tertiary maxima you are adding another lambda, so it's lambda by 2 plus 2 lambda, it's 5 lambda by 2. Correct? Fine. Okay. The exact same thing. And fringe width, you obviously know this is only for YDSC, but so yeah, this is what happens here. Yeah. Okay, fine. This is done. Okay, if the angles were specified in diffraction, okay, இப்போ இந்த கடைசி questionல the angles were specified, அப்போ you have to take the angles அப்படியே as it is. If it weren't specified, you can approximate it to be small. Okay, if they mention it small now, you can take it as y by dA. It's fine. Okay, all right. I think the entire chapter is over. It's a very simple chapter. So yeah, Okay, fine. All right. I think I'll take a leave, guys. See you guys the next week with modern physics. Okay. Thank you everyone who watched my video today. From Manu, Srinidhi, Balaji, Divakar, Safura, Harini, Kalai Selvan, Arasi, Jai Sundar, and so much people, so many other people as well. Yeah, you guys were commenting, so I just read your names. Thank you so much. Okay, bye bye. Okay, see you guys in the next class.